Winter on the open steppe does not arrive quietly. The wind rises first, sweeping across the land without obstruction, stripping heat from anything exposed. Temperatures fall rapidly, often plunging far below -40 degrees Celsius. Snow does not pile gently. It scours the ground, driven sideways by relentless gusts that can last for days. Across much of Mongolia, there are no forests to retreat into, no dense timber to burn, no permanent stone villages stocked with fuel for the season ahead. The land stretches outward in every direction, flat, open, and treeless. For nomadic herders, winter was not just a test of endurance, it was a test of foresight. Unlike settled societies that survive cold by stockpiling firewood or building massive shelters, Mongolian herders faced a harsher reality. Fuel was uncertain. Wood could be scarce or entirely absent. What little could be gathered had to last months. Burning more was never an option. Yet families survived generation after generation, not because they produced more heat, but because they learned how to lose less of it. Survival on the steppe depended on restraint rather than excess, on careful planning rather than constant fire. Every decision, where to camp, how to dress, when to burn fuel, was shaped by the knowledge that warmth was finite. This is the story of how Mongolian herders endured winter when firewood was never guaranteed, and how adaptation, not abundance, kept them alive. For Mongolian herders, winter survival did not begin with walls or fire. It began with movement. On the open steppe of Mongolia, remaining in one place for too long could be as dangerous as the cold itself. Grass disappeared beneath snow. Animals exhausted local forage. Fuel sources, already scarce, were quickly depleted. To survive, families had to keep moving. Unlike settled societies that built permanent winter shelters and stockpiled resources months in advance, nomadic herders followed their animals. Sheep, goats, horses, cattle, and camels were not just sources of food and clothing. They were the foundation of survival. When grazing failed in one area, the entire household had to relocate, sometimes every few weeks, even in winter. This made permanent buildings impossible. A stone house could not be carried. Heavy fuel stores could not be transported. Anything that could not move became a liability. Firewood, when available at all, was bulky and slow to gather. Storing enough to last an entire winter would have required wagons, roads, and forests that simply did not exist on the steppe. Mobility became the first and most important survival system. Homes had to be assembled quickly, dismantled just as fast, and rebuilt again and again in new locations. Heating methods had to work the same way. They needed to function whether a family camped in a sheltered valley, on an exposed plain, or beside a frozen riverbed. Solutions that worked only once or only in one place were useless. This constant movement shaped every design choice. Shelters were built to be light enough for animals to carry. Insulation had to be flexible and reusable. Fuel needed to come from what traveled with the herds themselves. Even daily routines adapted to the assumption that relocation was always possible, even in deep winter. On the steppe, survival was not about building stronger walls. It was about never becoming trapped by them. Mobility was not a lifestyle preference. It was the first defense against cold, hunger, and exhaustion, long before a single fire was ever lit. On the steppe, cold alone was not the greatest threat. Wind was. At sub-zero temperatures, moving air strips heat from the body far faster than still air ever could. A calm night at -30 degrees could be endured. Add strong wind, and survival time dropped dramatically. For Mongolian herders, controlling exposure mattered more than generating heat. The open landscape of Mongolia offered no natural windbreaks. Storms could sweep across hundreds of kilometers without slowing. In these conditions, a poorly shaped shelter became a liability. Flat walls caught the wind like sails. Sharp corners concentrated pressure. Rigid structures resisted force until they failed. Nomadic shelters evolved to solve this problem through physics rather than strength. Rounded forms allowed wind to flow around the structure instead of slamming into it. Curved walls reduced pressure points and eliminated corners where cold air could pool. By deflecting wind rather than stopping it, shelters lost less heat without burning additional fuel. Flexibility mattered just as much as shape. Structures that moved slightly under pressure absorbed energy instead of transferring it directly into joints and supports. When wind gusts hit, flexible frames dispersed force across many connections rather than concentrating stress in one place. This reduced both structural damage and the constant air infiltration that rapidly drained warmth from the interior. Reducing wind exposure produced immediate thermal benefits. When cold air cannot penetrate seams or force its way inside, the heat already present stays where it belongs. Every degree retained meant less fuel burned later. On the steppe, this difference could decide whether stored fuel lasted the season or ran out halfway through winter. Herders understood this intuitively. Winter camps were positioned with wind in mind, tucked behind hills or shallow rises whenever possible. Entrances were oriented away from prevailing winds. Even small reductions in airflow dramatically improved interior conditions. A slight drop in wind speed could make a space feel many degrees warmer without lighting a fire. Modern heating systems often focus on producing more energy. Steppe survival followed a different logic. Prevent heat from escaping, and the need to create it drops sharply. In an environment where fuel was never guaranteed, physics became a tool of survival. Shape, flexibility, and exposure determined whether warmth endured or vanished into the wind. On the fuel-poor steppe of Mongolia, warmth could not depend on constant fire. Instead, it had to be captured, stored, and reused. Wool became the answer, not as clothing alone, but as architecture. Felt transformed animal fiber into one of the most effective insulating materials ever used by nomadic societies. Wool works because of its structure. Each fiber is naturally crimped, creating millions of tiny air pockets when packed together. Air is a poor conductor of heat, and when trapped, it dramatically slows heat loss. Felt takes advantage of this property by compressing wool fibers into dense sheets that retain air while remaining flexible. The result is insulation that performs reliably even in extreme cold. Felt also manages moisture, a critical factor in winter survival. Wool fibers can absorb significant amounts of water vapor without feeling damp, pulling moisture away from the interior air. At the same time, felt sheds liquid water and snow, preventing melt from penetrating the shelter. This balance reduces condensation, keeps bedding dry, and prevents heat loss caused by evaporative cooling. Another advantage is thermal storage. Thick felt does not only block cold air, it absorbs heat when temperatures rise slightly during daylight or when a fire burns, then releases that heat slowly as temperatures drop. This buffering effect stabilizes interior conditions and reduces the need for continuous fuel use. A shelter wrapped in multiple felt layers cools gradually rather than rapidly, buying time through the coldest hours of the night. Layering was essential. In summer, a single felt covering might be sufficient. In winter, additional layers were added, sometimes 3 or more, each overlapping the seams beneath it. This eliminated gaps where wind could force cold air inside. The layers could be adjusted as conditions changed, thickened during severe cold and reduced again when temperatures rose. Insulation was not fixed, it was responsive. The production of felt was a communal effort. In warmer seasons, families gathered to process wool from their herds. The fibers were cleaned, spread in even layers, wetted, then rolled and compressed repeatedly. This mechanical action caused the fibers to interlock at a microscopic level, creating a dense, durable fabric without weaving. The process required time, labor, and coordination, but produced material that could last for years. Because felt came from the animals themselves, it traveled with the herders. It did not need forests, mines, or trade routes. Every migration carried the insulation needed for the next winter. This closed system was essential. When fuel could not be guaranteed, insulation had to compensate. By reducing heat loss at the source, layered felt transformed how much fuel was required. Fires became smaller and less frequent. Warmth lingered longer. On the steppe, wool was not just a byproduct of livestock, it was stored energy, engineered into shelter. Through felt, Mongolian herders turned fiber into warmth and scarcity into stability. If the walls of a winter shelter stopped the wind, the roof carried the greater burden. On the Mongolian steppe, snow did not fall lightly. Winter storms could deposit heavy, wet snow in short periods, followed by freezing temperatures that turned it into crushing weight. A failed roof meant more than discomfort. It meant exposure, collapse, and often death. To survive, Mongolian herders relied on a roof system that was both light enough to move and strong enough to endure extreme loads. The solution was not thickness or mass, but geometry. At the center of the structure sat a circular wooden ring known as the tuono, often called the sky ring. This single component allowed the entire roof to support itself through compression rather than brute strength. From the walls, dozens of wooden roof poles radiated upward and inward, each resting at one end on the lattice wall and at the other in precisely spaced holes around the tuono. Together, they formed a shallow cone. This shape served several critical functions at once. Snow naturally slid down the angled surface instead of accumulating. Rain and meltwater drained quickly. Most importantly, the weight that did remain was distributed evenly across all the roof poles. The engineering principle at work is compression. As snow presses down on the roof, the poles push inward against the tuono, creating a continuous ring of force. Rather than collapsing, the structure tightens. Added weight increases stability up to the material's limit. This is the same principle used in stone arches and domes, but here it was achieved with wood, rope, and precise proportions. Because the load was shared, no single pole carried excessive stress. There were no heavy beams, no internal columns, and no rigid joints that could snap under sudden pressure. The roof flexed slightly under changing conditions, absorbing stress rather than resisting it. This flexibility reduced failure during storms when wind and snow acted together. Heat retention was a direct benefit of this design. A collapsing roof would break insulation layers and create gaps where warm air could escape. By maintaining its shape under load, the roof preserved the thermal envelope of the shelter. The compact dome also minimized the volume of air that needed to be heated while preventing warm air from stagnating in unreachable corners. Material efficiency was critical. In Mongolia, timber suitable for construction was limited. Roof poles were slender and carefully selected for strength-to-weight ratio. The tuono itself was often carved from a single piece of hardwood and reused for generations. This economy of material allowed families to carry their entire roof system during migrations without sacrificing safety. Beyond engineering, the sky ring carried cultural meaning. It marked the opening between earth and sky, admitting light, air, and smoke. It framed the stars at night and regulated ventilation during storms. But its symbolism never overshadowed its function. The design endured because it worked. In extreme environments, survival favors systems that do more with less. The roof of the gear did exactly that. It resisted snow without mass, shed water without complexity, and protected heat without seals or fasteners. By relying on compression and balance instead of weight, Mongolian herders created a roof that could move with them, yet stand firm against the heaviest winter storms. On the open steppe, the greatest limitation was not cold, it was fuel. Across large parts of Mongolia, trees simply did not grow. The climate was too dry, the winds too strong, and the soils too thin to support forests. What little wood existed was often found far from winter pastures, making regular collection impractical or impossible. For nomadic herders, this reality shaped every decision about heat. Firewood could not be relied upon. Storing enough to last an entire winter would have required transport capacity that animals could not spare. Burning wood freely was never an option. Heat had to come from something that moved with the herds. That fuel was dried animal dung, known locally as argol. Collected from sheep, goats, cattle, and horses during warmer months, dung was shaped, dried, and stored specifically for winter use. While it may appear primitive, argol was exceptionally well suited to the steppe environment. When properly dried, it burned slowly and evenly, producing steady heat with minimal flame. Argol's efficiency mattered more than its intensity. It did not create roaring fires. Instead, it generated consistent warmth over long periods, ideal for small, enclosed spaces. It also produced far less smoke than green wood, reducing heat loss from excessive ventilation. In a fuel-scarce environment, clean combustion was essential. Fires inside winter shelters were deliberately kept small. Large flames consumed fuel too quickly and risked overheating the interior, forcing warm air to escape through openings. Small controlled fires, tended carefully, provided just enough heat to raise temperatures slightly and recharge the insulation layers. Once the felt walls absorbed that heat, the fire could be allowed to die down. This approach treated fire as a supplement rather than a foundation. Warmth did not come primarily from burning fuel. It came from retaining heat already present. The stove's role was to compensate for unavoidable losses, not to overpower the cold outside. By burning less, herders ensured their limited fuel supplies lasted through the longest winters. Stoves themselves reflected this philosophy. Compact and centrally placed, they maximized radiant heat while minimizing fuel consumption. Chimneys were designed to draw efficiently, providing airflow without pulling warmth out of the shelter. Every aspect of the system prioritized balance over output. In environments where fuel is abundant, heat is often wasted. On the Mongolian steppe, waste meant risk. By relying on dung fuel, controlling fire size, and integrating heat with insulation and shelter design, herders created a system where warmth could exist even when wood did not. Fire was not the solution. It was one carefully managed part of a much larger survival strategy. Inside the circular space of a winter shelter, survival depended as much on behavior as on construction. Every action, where people sat, slept, and moved, affected how heat was shared and preserved. In a world where fuel was limited, daily life itself became a tool for conserving warmth. The central heat source defined the layout. Sleeping areas were arranged around it in a careful order, with the most vulnerable members placed where warmth lingered longest. Thick felt mats and layered bedding were rolled out at night and packed away during the day, keeping floor space open while allowing insulation to be positioned exactly where it was needed. Clothing played a crucial role. Herders did not undress indoors in winter. Layered wool garments, boots, and hats were worn inside as well as outside, reducing the demand placed on the stove. Warmth was carried on the body rather than produced by burning fuel. This habit dramatically lowered the amount of heat required to maintain comfort. Social order replaced physical barriers. In the absence of separate rooms, space was divided by tradition and custom rather than walls. Each family member knew where they belonged, and movement within the shelter followed established patterns. This reduced unnecessary circulation of cold air and prevented disruption of the warm interior environment. Objects were placed with purpose. Storage chests lined the walls, adding insulation while keeping possessions organized. Frequently used items were kept close at hand to minimize time spent near the door. Even entering and exiting followed discipline. Doors were opened briefly, then closed quickly, limiting heat loss. These routines were learned early and practiced daily. Discipline was not enforced through rules, but through necessity. In Mongolia, small inefficiencies accumulated quickly. A door left open too long or a fire fed too heavily could cost precious fuel. By organizing life around heat rather than convenience, Mongolian herders created an interior system that worked as efficiently as the shelter itself. Survival was not just built into walls and roofs. It was embedded in habits, relationships, and the quiet order of daily life. The winter systems developed by Mongolian herders were shaped by necessity, but their principles extend far beyond the steppe. In an environment where fuel was limited and conditions unforgiving, survival depended on reducing demand rather than increasing supply. That logic remains relevant wherever energy is scarce, expensive, or unreliable. One lesson is the importance of controlling exposure before producing heat. The herders' first solutions addressed wind, insulation, and layout, not fire. Modern buildings often reverse this order, relying on powerful heating systems to compensate for heat loss. The steppe approach demonstrates that preventing loss is often more effective than generating warmth. Another principle is efficiency through simplicity. Instead of complex systems, herders relied on materials and designs that performed multiple functions at once, felt insulated, stored heat, and managed moisture. Structural elements provided strength without excess weight. Each component justified its presence by doing more than one job. The idea of treating heat as a supplement rather than a constant also challenges modern habits. Continuous heating encourages waste. Intermittent, controlled heat encourages awareness. By allowing temperatures to fluctuate slightly while maintaining overall comfort, herders reduced fuel use without sacrificing safety. Finally, these systems worked because they integrated human behavior into design. Clothing, movement, and social order were as important as walls and roofs. Technology alone did not solve the problem. Discipline and adaptation did. The steppe teaches that resilience does not require abundance. It requires understanding limits and working within them. In a world increasingly defined by energy uncertainty, the solutions developed by Mongolian herders offer more than historical insight. They offer a reminder that efficiency, flexibility, and restraint can be as powerful as any modern system. Enduring winter on the steppe was never about overpowering nature. It was about learning when to yield and when to adapt. Mongolian herders survived not by building heavier structures or burning more fuel, but by staying flexible. They moved when the land demanded it. They conserved when resources were thin. They designed homes and habits that worked with wind, cold, and scarcity rather than against them. In Mongolia, resilience came from restraint, from knowing that warmth could be preserved as much as it could be produced, from understanding that survival depended on systems that could bend, relocate, and recover. Nothing was fixed. Everything was prepared to change. The steppe rewarded those who listened closely to its limits. Over generations, herders learned that true strength was not found in resisting the environment, but in aligning with it. Their survival was not an act of domination. It was an ongoing conversation with the land, one built on movement, balance, and the quiet discipline of enduring. But enduring the steppe is just one thing. When the fire burned low and the steppe fell silent in Mongolia, how did Mongolian families sleep through the coldest nights of winter without freezing to death?